Hey, we've all been there, right? You get a test result back, you stare at this number, and you just wonder, what does it actually mean? I mean, a 5 on one test can be amazing, but a 50 on another could be a total disaster. Well, today, we're going to pull back the curtain and demystify test scores. We're going to learn how to translate those lonely numbers into something that really makes sense. So let's dive in.
Okay, let's just jump right into a scenario. Picture this. You take a test, say 20 questions, and you get this score back, 18. So, is that good? Is it average? Should you be celebrating or should you be a little worried? What can this single number really tell us? On its own, not much. A score of 18 is what's called a raw score. It's just the original untouched number. But without any context, it's pretty much meaningless. We have no idea how tough the test was, and maybe most importantly, we have no idea how everyone else did. To make this number mean something, we have to compare it. And our first tool for adding that context is all about comparison. It's a way to find your exact place in the crowd. We're talking about percentiles. Now, it is so easy to get this one wrong. A percentile rank is not the percentage of questions you got right. No. Instead, it's the percentage of people who scored lower than you did. It's what's known as a norm reference score, which is just a fancy way of saying its entire meaning comes from comparing you to the rest of the group. And the process for figuring it out? It's actually super simple. Just imagine lining up every single score from the lowest to the highest. All you have to do is count how many people scored less than you, and then you just turn that number into a percentage of the whole group. That's it. So let's actually do this with our score of 18. Let's say we're in a group of 50 people who took the test, and it turns out that 41 of those people scored lower than 18. That simple count, that 41, that's the key to everything. And boom, just like that, we have our context. 41 out of 50 people is 82%. So our score of 18 puts us in the 82nd percentile. All of a sudden, that lonely number tells a story. It says you performed better than 82% of your peers. See, now that feels meaningful. But what if we want to see the bigger picture? Not just where we stand, but the entire landscape of all the scores. Well, to do that, we need to uncover this kind of secret map that's hidden inside the data. Okay, so every good map needs a starting point, right? A "you are here" marker. In the world of stats, that's the mean. It's just the simple mathematical average of all the scores. A great way to think of it is as the perfect balancing point, like the fulcrum of a seesaw for the whole group of scores. Next up, our map needs a scale. We need a way to measure distance. And that's where the standard deviation comes in. It basically tells us, on average, how far each score is from that center point, the mean. So a really small standard deviation means all the scores are bunched up together, while a big one means they're really spread out. And here is where the magic happens. When you measure almost anything in the natural world, I'm talking height, weight, test scores, you name it, and you plot all those data points on a graph, this beautiful, predictable, and really powerful shape starts to emerge. You've seen it before. It's the normal curve, but everyone knows it as the bell curve. And this shape tells us something kind of universal. Most results, most people, cluster right around the average, smack in the middle. The really extreme scores, both high and low, are way, way rarer. And that's why the curve is so high in the center and just slopes down at the edges. And here's the really cool part. It's incredibly predictable. About 68%, more than 2/3 of all scores will fall within one standard deviation of the mean. If you go out to 2 standard deviations, you've captured about 95% of everyone. This consistent pattern is the secret to figuring out exactly where any single score fits in. So we have our map, the bell curve. We have our scale, the standard deviation. Now we just need a tool to pinpoint our exact location on that map. This tool is a type of standard score, and it works kind of like a universal translator for data. It's called a z-score, and its job is really simple, but it's incredibly powerful. It tells you the precise number of standard deviations your raw score is away from the group's average. Is your score about average, below, and by exactly how much? The z-score gives you the answer loud and clear. So let's calculate this for our score of 18. The average score for our group, the mean, was 13, and the standard deviation was 5. So our score of 18 is 5 points above that mean of 13. And since one standard deviation is 5 points, Well, that means we are exactly one standard deviation above the mean. Our z-score is a nice clean plus 1.0. This z-score of plus 1.0 gives our raw score a precise GPS coordinate right on the bell curve. We're not just above average anymore. We are exactly one standard unit of measurement above the center of the entire group. This is what makes z-scores so powerful. They let you compare an apple from one test to an orange from a completely different test. Now, z-scores are amazing, but let's be honest, telling someone their score is negative 1.2 can sound a little harsh, and decimals can be confusing. So to make things a bit more user-friendly, we often convert z-scores into what are called t-scores. A t-score just sets the average at a nice round 50 and makes each standard deviation worth 10 points. It's a simple trick, but it gets rid of all the negative numbers and decimals, making the results way easier to talk about. All right, let's pull all of this together and take a look back at the incredible journey our simple little score has taken. We started with a raw score of 18, just a lonely number. Then we gave it a rank, a percentile, and we learned it was in the 82nd percentile. After that, we found its precise location on the map with a z-score of plus 1.0. And finally, we turned that into a nice, friendly t-score of 60. We've literally transformed a meaningless number into a rich piece of information. So why does any of this matter? Because context is everything. These tools let us make fair apples-to-apples comparisons, even between something like an English test and a chemistry test. But most importantly, understanding these basic stats empowers you. You don't have to just stare at a number anymore. Now you can actually read the story behind it. So, the next time you see a test score, you'll know. You'll know it's so much more than just a number. It's got a rank, it's got a location, and it's got a story to tell. The only question is, how are you going to read it?